This conference.
So today we'll talk about what is Hive UDF. So inside this Hive UDF topic, we'll see what is the purpose, first of all. In the second part, we'll talk about what is the use case of Hive UDF, real-time typical use case. And the third thing which we'll do is to create and use the UDF which we have written. So custom UDF basically. Okay, so what is the purpose? So basically, we have seen all these functions, right? Hive functions which were there, the built-in Hive functions. We have mathematical. We have seen a lot of mathematical functions. So again, you can refer the Hive documentation for that, and you'll be able to see a lot and lot of mathematical functions, collection functions, string functions, and conditional functions, and date functions. So the date functions also we have gone through that the previous day. There are a lot of these functions which are there, and each of them are actually very different and are serving its own purposes. So we did not talk about this collection functions. Okay, so once we finish our complex data types, we'll talk about the collection functions. So yeah, so this is it on the built-in functions which I've seen. So let's say, suppose you got a scenario or a use case, okay, where all these built-in functions which are there, like some odd more than 150 to 100 built-in functions are there, like together. So in your scenario or use case, your requirement would not be fulfilled even after using any of these built-in functions. So in that case, you have to come up with some approach, right? So there should be some way programmatically, anything you could achieve. So that way is nothing but your Hive UDF. So this Hive UDF is your way or path to that particular thing. Okay. So basically, you create a UDF, which is nothing but user defined function. So you implement your own logic, you implement your own requirement which you have, and then based on that logic and requirement in mind, you do the implementation part. So that is the purpose of the Hive UDF first of all. So whatever the built-in functions which are not available, so based on that you come to a decision that here you have to come to a path that you need to create a user-defined function. So now you know what is the purpose of this UDF now, right? So you know that why do we basically create a custom UDF. But in real time, what kind of UDFs do you usually create is what we'll talk about now. Okay, so this comes to the second part, which is the use case of Hive UDF. So what could be the real-time use cases? So there are actually endless use cases. Okay, so if you talk about in reality these 50 or 100 functions which are there, though the number looks oh wow, but in real time sometimes you'll have so critical or complex use cases that none of those built-in functions would actually help you. So that's why there are endless use cases, there are many use cases, but for some, if you see, uh, you maybe come up with like for basically you'll have to create this UDF for creating custom partitionings. So we'll talk about what is this partition. I've not talked yet what is this custom partitioning meant. And then you have a use case where you can create formatted dates as partitions. Okay, so this is the second use case. And third use case is whenever you use an external library. Okay, so in scenarios where you have to use some external library and then you have to use that external library to achieve something or achieve some use case in your requirement. Okay, external library or third party libraries, like whatever it is. Okay, so in order to achieve this, again you have to come up with a new approach called Hive UDF. So again, Hive UDF is purely Java. So you're writing your entire Java code here. Okay, so there are many use cases, like for now this three, and like these three are something which I faced in my real time, but there are actually many based on the requirements. So you may ask me, like, what do you mean by external library? What third party libraries? So a best example for this which I have experienced in my real time is a concept called Geo to IP. Okay, sorry, IP to Geo it should be. IP to Geo. Okay, so what this library will do is, this is a third party library. It is a vendor library. Okay, third party. Uh, it's usually open source, but if you wanted to leverage more functionality about this library, then you have to come up with a like enterprise one. Okay, so you need to pay some dollars in order to use this library. So you can't straight away use it because in companies usually they'll be using enterprise ones. So we have got license to this library. So we have to import this library now. So the basic functionality of this library is, what it will do is, it will take an input of IP address. Okay, so this IP address could be something like this in real time. And then after taking an input of this IP address, you get an output. Okay, so once you input this IP address to this library, you get an output from this library, from the same library, which will be the country, which will be the state and region for this particular IP address. Okay, so whatever the country, state, region which belongs to this library, all that information you get as an output out of this IP to Geo library. Okay, so that is the purpose of your external third party libraries. So this is a simple example. Like using built-in functions, you can't achieve this at any cost. So you can't use any of these functions, which we'll call a third-party library, right? So that's why you have to come up with a custom UDF. And once I use that custom UDF, I just give an input of this IP address, and then I just get an output, which will something be like this. Okay, the state, country, and the regions. Again, like once I get this information, I'll do a lot of other processing. So with this IP address, it is very difficult to identify where a particular user is calling from. So basically this third party library, the project which I've used is an API management project. Okay, it's an API management project, and in which we get a lot of web server logs. Okay, and this web server logs are having a lot of content, a lot of logs which are continuously generated. And inside that logs, there is also one field which is IP address. Okay, and basically it will also have which page that particular user has visited, the cookie information, and a lot of other different website related stuff. So with this IP address, it's very difficult that where that user is calling from, right? So that's why we have come up with this approach of using a third party library, and inside this third party library we have implemented in a such a way that we call the input of IP address and we get an output of the different regions associated for this particular IP address. Okay, so this is how we have used a typical use case of Hive UDF
Will now be recorded.
in order to achieve this Hive custom UDF thing. The first one is to create a Java class to a library which is called as this one. Okay, you need to extend all your functionality to this. Extend your Java class functionality to the Hadoop library Hive UDF, and then to this library. So once you extend that, you'll be able to extend your functionality to this. And in the third step, you need to create an evaluate method. Okay, so this method would be the actual call for your Hive UDF. And then the fourth step would be to actually package your jar file. Okay, so you need to package your entire jar file because you can't run a Java class file, right? You need to package that. And then in the fifth step, you need to basically add this jar file in the terminal. So whatever terminal which you wanted to access, you can simply add that jar file. Okay, so once you add that jar file will be available for accessing. And you need to create a temporary function. Okay, so in this temporary function, you give some name to that function, maybe xyz or something like that. And you can just use this xyz function in your select statement, which would be the second step, I mean the seventh step. Select xyz and then you call it directly. Okay, so this would be my 6 to 7 steps, simple steps in order to create that custom UDF. Okay, so I'm going to achieve all of this. I'll try to explain all of this different steps for a use case called strip. So what this strip function will do is it will basically remove the extra spaces or the extra characters in a given input. So let's say this is my given input, space, 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 Hadoop. Okay, when I give this input to my function, which I'll be calling as xyz, okay, so when I give it to that xyz, it will return me Hadoop. It will just remove the white spaces. And similarly, if I just give instead of white spaces, I give it as something like this, hash hash hash. And in the second argument, I give that hash is the symbol which I wanted to remove. Again, it will give me an output like this. Okay, so this is how I wanted to achieve. So once I do that, you just add all your libraries which are required for us using the Maven dependencies, and then give it a name as strip. And then in the Hive UDF, if you see my project name, you will be able to see the Maven dependencies project after adding the relevant dependencies into the pom.xml file. Okay, and then inside this functionality, I've written this functionality where uh, I'm just taking an input of a string, and in the second argument, I'm just giving the characters which I wanted to strip. And then I'm first checking if it is null. Basically, if it is null, then just return it null. If it is not null, then I'm returning the value after removing the strip characters. Okay, so I'm using this function over here. So this would be my evaluate method with two arguments, and then I'll also have an evaluate method which will have one argument, which will only take a string as an input, and again it will do some null check over here, and then finally it will again strip the white spaces from my input string characters. Okay, so once that is done, you can just right click on this project and then go to your run as maven install, and then it will install your entire package. Once it is installed, you will be able to see a library, or you'll be able to see a folder called as target over here, and the target name, and it will create a Java file basically. Okay, so this Java file is also created based on the information which we have added in the pom.xml file. So if you see in the pom.xml, our group ID's name is Hive UDFs, and the artifact name is Hive UDF, and that is what it also created over here, Hive UDFs. And then the version of our jar file, it is 0.0.1 dash snapshot, and the same version is also given over here. And because uh, extension is jar, we got a .jar file. And this versioning is important in real time. So for each release or uh, each change which you make for your source code, you just assign a version and then build that jar file so that your history is maintained for your jar files. So this versioning is important. Okay, so once you can see that your console is having an build success message, that means your library successfully created this jar file. Okay, so this is done. Now the first step is done to create a Java class. Second step to extend the Java class is done, and third step to create an evaluate method is also done, and the fourth step to package your jar file is also done. Now you have this jar file, right? So just straight away come to a Hive terminal. You just open a Hive terminal. Just type and then you'll enter into this terminal. Now in this space, you just add the jar file. So how do you add it? You maybe go to this jar file and click on properties. You'll be able to see the entire file name, right? So just click on that file name and then insert, and then you can see a message that added. Okay, it says this entire jar file is added to the class path. So to confirm if this jar file is added or not, there is a command in Hive called as list and then jars. List all the jar files which are currently available in this particular session of Hive terminal. And then you can see some default libraries which will be already there. And along with that, we'll also be seeing the Hive UDF jar file, so which is our custom UDF jar file. Okay. And this jar file is only available for this instance of Hive terminal only. So this jar file is available. Now the next step is to create a temporary function. So in order to create a temporary function, there is again a command in Hive where you create a temporary function. So there is a command same as that. And then you give a name to that function. I'm giving strip in this case. And then you need to say as. After saying as, you need to mention your entire package name. That function is created. Now you could straight away use that again in your as a normal function over here. And if you just give it a single argument, it will call the single argument evaluate method and then return you by removing the white spaces. And similarly, if you just add some weird characters and then say that that weird character is dollar and remove that, and then it will also do the same. Okay, so this is how you have achieved the custom UDF, where we have seen all these 7 steps and we have written our own functionality over here. Okay, thank you.